All right, here we are in Cura. Cura is a slicing program. I won't go into a whole lot of detail about it, but basically what a slicing program is it takes a 3D object file and turns it into a map that a 3D printer can follow to build the physical copy of the 3D object. There are a lot of different ones. Cura is the one I use. So we have to import our peg into this and set all of the 3D printer settings for it so that we can get it to print the physical copy so that we can actually test it. So let's do that. Okay, so I did rename that file, so it is now peg test for our bracket. And there it is. See, it's not real big, so it takes up a very small area on the 3D printer. This basically the checkered area represents the bed of the 3D printer, for those of you who don't know. So as soon as I dropped it in, without changing any settings, it has given me an estimated print time of 13 minutes, which for a 3D printer is not that bad, but then again, it's a very small object. So, I mean, on my printer alone, I could build something like this. Cube represents the entirety of the build volume for my 3D printer. If I picked an object that covered most of that area, it could take better than a day to print. So yeah, 13 minutes isn't that bad. All right, so let's see here. We'll change our settings. Okay, so we will be printing in PLA plastic. That is my 3D printer. We can go with a little bit bigger layer height on this, I think. So 0.4 nozzle, so let's go with 0.3. The wall thickness and stuff is fine because it doesn't need to hold any weight or anything. This is what the outside of the object will have in terms of its layer thickness. So, and it's set for 0.6 millimeters, like I said, which is just fine. Because it's not going to be actually holding any weight. So we're just using it to test whether or not I got the sizes right. Infill density is 30%, and that basically it puts a little grid of plastic inside so it's not completely hollow. And it defaults to 30, and 30 is just fine. I mean, it probably doesn't even need that, but it's okay. Print temperature and build plate temperature, those are fine. That I use that diameter. I don't need to modify the flow. We do want retraction. That should be just fine because it's pretty tight. Oh, you know what? I already messed up. I forgot that because they like to. You can't remember how to move myself in, but so you can see where the little divot is. I need to put a ramp on that. So I should have made like a cone. Well, not a cone, I guess, but it needs a more gradual connection between, so that the plastic that is on the nub at the end of the peg has something to hold on to as it builds up. I completely negated doing that, so that's, you know, we live and we learn. Okay, so I will be popping back over to Tinkercad and correcting that issue, and then we'll come back and do this. Back in a sec. Okay, back in Tinkercad now. Let's see what we can't do about giving that a bit of a gradual edge. Maybe we could do, yeah, let's try that. We'll do a little bit of a half sphere. And then we'll size that down. So what was our diameter here? 3/8. 3/8. Oop. 3/8. Okay, and then it doesn't have to be very tall because it just needs to get the point across. So let's go. No, 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 don't need to be lifted up. At least not yet. We need to raise the height. To, oh come on, 0.18. Yeah, 1/8 should be fine. And then, now we can pick it up. And we'll turn it over. And well, we'll find out if it's close to over the top of it or not. Oh, we didn't get it quite right. So, there we go. And then no, we don't want it. Maybe we want it a little not so. Yeah, let's take it down even more now that we have the direct reference here. All right, what do we think about that? That gives us a nice little lip for the 3D printer to build up on, and it still gives plenty of should give us plenty of clearance. Well, let's err on the side of caution here and go up a step with all of it, like that. And then this will be for bracket number 2, and we'll export that, everything. Okay, that should do it. Now let's pop back into Cura. Let's open the new one, number 2. All right, and we probably won't be able to see it. Oh yeah, you can see it just a little bit. Okay, and we'll see. I don't know if that's going to be enough of a build area to keep that from needing supports, but we will try it. It won't take very long to print, so that is the good news. All right, so let's go back through this and make sure we've got everything. Layer height, yep. Okay, yeah, and we're not going to enable support if we don't have to. Okay, I think that will do it for us. So now I can turn this object into a G-code file for the 3D printer, and we'll see what we get. And do I want to save to my removable drive? Yes, but I don't have the right memory card in there. Okay. And there we have it. So I will see you at the 3D printer. All right, so here we are. It printed. It looks pretty good, actually. So let's see whether or not it does the job. So we're shooting for right there. And so what it needs to do is the big part needs to be able to fit inside the round part of the keyhole. And then the narrow part needs to be able to glide along the tooth part of the keyhole. And we want it to be movable but snug, so that way nothing slides around much when it's in position. So let's see if we got it to go. Okay, it goes into the keyhole, but does not move down into the teeth. So based on the thickness of the plastic, I don't think it's because this isn't deep enough. I think it's because the round part of our peg is still too thick. But yeah, I like the big part that fits. I mean, it just fits in there, so that's nice because that means it'll have a reduced likelihood of falling out from shifting around, or like bumping the table, because I mean the 3D printer wobbles a little bit because the table of it actually moves, so it's constantly going and so with it nice and snug like that, we know that it isn't going to come out very likely. But it looks like, I think we've got a lot of depth in both of those holes. So what I think I'm going to do is I'm going to make the whole peg longer a little bit, not by a ton, and then leave the nub, the big part of the pin, alone. I won't change the size of that, but I'm going to make the neck of it, the peg itself, just a little bit narrower. And then we might do some further tweaking in the program for the 3D printer to make sure that we're getting it as accurate as possible. But yeah, no, I mean, for a first time, we're pretty good. It's close. I think going with a 1/4 inch thick is probably more than I need. So I might thin that down a little bit, but I don't think I'm going to go crazy. Like maybe 1/3 of the way tops. Like somewhere between a 1/4 and, or I mean between an 1/8 and a 1/4. Yeah, no, we'll see what happens. No, I'm pretty glad that it's close though. Oh, and the other thing I wanted to mention. So the reason why I did an inch square is because I wanted to see how big of a footprint it had as it sat in the light. And so as you can see here, that's 1 inch. I think I'm going to go and make it a little bit wider, like another 1/2 inch. So it'll be like that. And then that one way it'll come up and over like this to hug the glass. It's got a little bit more of a footprint to help it stay in place. Because I'm not going to go fancy and put like rubber in there or anything like that. I'm just going to have it hang off of what I print. So, so I figure making them a little wider will probably help. But that is for when we get to that part. But I wanted to use a 1 inch as a gauge to see whether or not that was going to do. And it looks like I want it a little bit wider. So anyway, we'll get to that when we get to that. Back to Tinkercad.